So the Mars Science Laboratory mission is NASA's next rover to go to Mars, which will assess the past and present habitability or ability to sustain life on the surface of the red planet. The MSL rover, called Curiosity, is about the size of a Mini Cooper, and it has 10 instruments on board, all designed to measure or search for elements or building blocks of life, or to measure factors which limit the ability to sustain life. Southwest Research Institute led the development of the Radiation Assessment Detector, or RAD. RAD is an energetic particle analyzer which will measure both charged particle and neutral particle radiation, both on the surface and in space. RAD is about the size of a coffee can and weighs about 3 pounds and has the capability of many instruments on Earth which are about 10 times the size. On Earth, we're protected from the radiation environment in space, both by our atmosphere as well as the magnetic field, or magnetosphere, which provides a buffer from the charged particles which would otherwise hit the surface. Mars is different both because its atmosphere is only 1% the thickness of Earth, and it doesn't have an inherent magnetic field to repel the charged particles. So there's two primary sources of radiation which are important on the surface of Mars. Galactic cosmic rays, which are high energy particles coming from supernova remnants far off in the galaxy. And then there's solar energetic particles, which come from the sun during solar maximum or around solar maximum, which are the result of solar storms or coronal mass ejections on the surface of the sun. RAD will measure the radiation environment on Mars as a limiting factor to life or habitability, as well as to be used as a planning tool for future human exploration of Mars. RAD will measure the radiation environment both on the surface of Mars and on the long journey between Earth and Mars, because both contribute to the radiation environment that an astronaut will see on a future human mission. So RAD will characterize the radiation environment on the surface of Mars as a function of time, essentially every hour for the entire nominal 2-year mission, as well as throughout an extended mission which we hope will last as long as a solar cycle. RAD is unique because we will be able to measure for the first time the radiation environment on the surface of another planet, and this has never been done before.